Okay, so we are to Unit 5, Lesson 1. And in Unit 5, we are going to talk about congruence, and more specifically, special congruence in triangles. So to understand that congruence, we need to understand triangles, and how their angles and how their sides classify them. So in this lesson, we're going to talk about specifically the angles in triangles. So this first kind of table here organizes how we classify triangles by their sides and how we classify them by their angles. So first, classifying triangles by their sides. A scalene triangle is a triangle that has no congruent sides. No two sides are the same length. An isosceles triangle is a triangle that has at least two congruent sides, okay? So two congruent sides means it's isosceles. And then an equilateral triangle is a triangle with three congruent sides. So all three sides would be congruent. So the idea is an equilateral triangle is actually an isosceles triangle, but it's a little more specific. So equilateral is three congruent sides, isosceles is two or more congruent sides. Classifying triangles by their angles. An acute triangle is a triangle with three acute angles. Okay, all of its angles are acute, so that kind of makes sense. A right triangle is a triangle with one right angle. One right angle. All right? And then an obtuse triangle has one obtuse angle. A triangle can't have more than one obtuse angle. So an obtuse triangle has one obtuse angle. And then an equiangular triangle is a triangle where all three angles are congruent. So those are the ways we can classify triangles by their angles. Now, with these three examples, we're going to classify triangles by their sides and their angles. So in this first triangle, we have nothing marked as congruent as far as sides go. So this triangle would be scalene. That's me classifying it by its sides, and then classifying it by its angles. It has this one right angle. So this is a scalene right triangle. None of the sides are congruent, and it has one right angle. So that's a scalene right triangle. The second one, classifying it by its sides, we see it has two congruent sides. So this triangle is isosceles. And none of the angles are marked as congruent. None of them are marked as right. We can assume that they're all acute. So this is an isosceles acute triangle. And then the last one, when we look at it, none of the sides are marked as congruent, so we can say that by its sides, this is scalene again. Looks like this angle right here is definitely bigger than 90, so I'm going to say that this is also a scalene obtuse triangle. So that's how we classify. I'll fix that. That's how we classify by sides and angles. Okay, classifying by sides and angles. So specifically, how can we classify a triangle when it's in the coordinate plane like this? Well, classifying it by its sides and determining whether it's a right angle. The first thing I'm going to say with this triangle, looking at it logically, is this definitely isn't an equilateral triangle. Because if you look at the sides, and I'm going to highlight a little bit here, these three sides are definitely not the same length. So equilateral is out of the question. I'm saying it might be isosceles because these two longer sides look like they might be the same length. So what I'd have to do to see if this was isosceles is I would compare PQ, the length of PQ, and then the length of OQ. And you may not like this, but this goes back to that distance formula. The square root of x2 minus x1 plus y2 minus y1 squared. Okay, so to find the distance of PQ, that would be the square root of, I would do 6 minus -1 squared, and then 3 minus 2 squared. So that would be the square root of 6 minus -1 is 7. 7 squared is 49. 3 minus 2 is 1. 1 squared is 1. So this would be the square root of 50. And I'm just going to leave that alone. This is PQ's length. That is good to know. All right? And then OQ has to be exactly the square root of 50, else they are not the same length, and it's not isosceles. So I'm going to take OQ, x2 minus x1. This one's a little bit easier. 6 minus 0 squared, and then 3 minus 0 squared. So this is the square root of 6 squared is 36. 3 squared is 9. That's the square root of 45. So OQ, fix that, OQ is the square root of 45. So what I can say, at least for the sides of this triangle, classifying it, I know this triangle is scalene. And the reason I know it's scalene is because definitely these two sides are not equal. I proved that mathematically. And then looking at this other side, it's definitely shorter, all right? I know I tell you not to assume things, but when we look at this, we can tell, this side length is much, much shorter. PO is much shorter than the other two. So it's comparing those two that might be isosceles. Now, here, what I'm going to do to see if I can classify it by its angles, to see if it has a right angle, is I'm going to compare the slopes of two sides. So what I'll do right now is I'm going to compare the slopes of OP and the slope of OQ. Because if those two meet at a right angle, I'm just assuming, then they would have opposite reciprocals of slopes. So the slope of OP would be, y2 minus y1, 0 minus 2 over 0 minus -1. Well, that's -2 over +1. And let's just leave that for right now. The slope of OQ, I would do 3 minus 0, 6 minus 0. So that would be 3 over 6, which is 1 over 2. Now, if we look at those are opposite signs. They are reciprocals. So this is a right angle. So this is scalene and right. So it's about remembering that distance formula and slope. So that's a lot in one problem to do. But it's mostly about us knowing how to look at it and classify those triangles by their sides and by their angles. So the next example, maybe the most practical one that we're going to use from here on out, that we're going to use a lot in the future, is this triangle sum theorem. All right? And what this theorem says is that in any triangle, if I add up all three of the angles, angle A plus angle B plus angle C, those angles will always add to equal 180 degrees. So that is a big, big, big theorem in geometry, knowing that the sum of the angles in a triangle is 180. So what we're going to do is we're going to get some practice finding a missing angle and then classifying it by its angles. So in this triangle, I know that angle 1, the measure of angle 1, I'll say, the measure of angle 1 plus 78 plus 31 is 180. So the measure of angle 1 plus, if I add those together, that's 109 equals 180. So the measure of angle 1 is really 180 minus 109. So the measure of angle 1 is 71 degrees. Okay? The measure of angle 1 is 71 degrees. And from that, the way I can classify, well, if I look at all three of these angles, all three of them are acute, so this triangle is acute. So essentially I take 180 minus the two known angles to find my unknown angle. So there's a couple different ways to do it. I did it using an equation, but you guys, you can use it whatever method you want. So in this next one, let's just look at the measure of angle 1. We know it's 180 minus 40 minus 30. So 180 minus 40 is 140, 140 minus 30. The measure of angle 1 is 110 degrees, making this triangle obtuse because it has one obtuse angle. And then this last one, if you want to find the measure of angle 1, I would take 180 minus 60 minus 60. The measure of angle 1 turns out to be 60 itself. And then what I can say from that, all of the angles are the same measure. So this triangle is equiangular. Okay, equiangular. So if you're trying to find the third angle in a triangle, we know the angles in a triangle always add up to equal 180 degrees. Their sum is 180 degrees. So that is a big, big thing that we're going to use continually throughout the rest of this year. So just getting a little bit of practice with that and classifying the angles. Okay, and then now we talked about the interior angles of a triangle. Now this is a little less common, but it's still something that shows up. So the exterior angle theorem. What this means is if I have two triangles, if I have a triangle and two interior angles and an exterior angle, meaning if I extended one of the sides of a triangle, that forms an exterior angle. These two interior angles add to equal that exterior angle. So they have to be the two angles that are opposite from that exterior angle. So if I'm going to find a missing angle, like in this example 4, the equation I set up is these two interior angles add to equal, so x plus 70, they add to equal that exterior angle. So that becomes an equation I can solve. I can subtract x from both sides. 70 equals x minus 5. I add 5 to both sides. 75 equals x. Now that's really not what I was looking for yet. I got x is 75, but I'm trying to find JKM, which is this angle right here. So I would go back and I would say the measure of JKM is 2 times 75 minus 5. So I'm just substituting my known value for x into the expression for JKM. So that's 150 minus 5. It's 145 degrees. So it's just saying the two opposite angles, interior angles to that exterior angle, the sum of them equals that exterior angle. All right? And then the last thing with the triangle sum theorem. You can use the triangle sum theorem for this too. This is just kind of a shortcut. If I have a right triangle that has, my other two acute angles, I know that this angle plus this angle, A plus B, is equal to 90. Because if I take 180 minus 90, I get 90. So it's just saying, to find these other two acute angles, I would just say that they add to equal 90. So in this example, find the measure of each acute angle. I know that these two acute angles, 2x and x minus 6, add to equal 90. Now I could do 2x plus x minus 6 plus 90 equals 180. This is just a shortcut to that. So to solve this, this would be 3x minus 6 equals 90. 3x equals 96. X equals 32. My job isn't done though, because I have to find the measures of both angles. So let's just use angle 1, angle 2, just to keep some consistency or some organization here. So angle 1 would be 2 times 32, which would be 64. If I was finding the measure of angle 2, it would be 32 minus 6, which would be 26 degrees. And if you wanted to check, you could do 64 to make sure you did it right. 64 plus 26 plus 90, that should equal 180 if you know you're adding them and setting up the equations correctly. So there's always a way to check your solutions to verify that you're doing the setting up, the solving, the substituting correctly. So that is a big thing. So make sure that you're taking your time with problems like this, referencing back to the notes, and doing your best to understand it and ask questions if you don't understand it. So you can move on to the quizzes. That is now your practice. The paper and pencil practice, I'm still going to encourage it, but it is not required for you to do the paper and pencil practice. I am requiring the quizzes now. That counts as your practice grade for these lessons. So if you have any questions or if you need something modified, you got to let me know, all right? You got to communicate. Email's the best way. So you can move on to the next step in this lesson.